Okay, so I asked you to do what is about 10 problems, yes?
Yeah.
Okay, so if you could kind of gather them together at your table, and then we're going to hand them in.
Do you have a stapler?
I don't have, well, I don't, but as long as you just keep them, yeah, if your name's on the first page, I'll keep them in order. You don't need to fold it, don't worry about it. I do a pretty good job of keeping things together. And I'll staple them as I grade them.
It was the 11 through 20, right?
Yeah, 11 through 20?
Yeah.
Were there any issues with those?
The only thing
Pretty
I
straightforward?
did, because of my calculator, I would do the square root, and I would actually put down the actual
Did
number.
you get better at that?
Yeah.
Okay,
No, just
good.
to make sure I was doing it in my calculator right.
Yeah,
So it was a little bit long, but it's all right.
okay. Its names on it. Go. Take your time. All done? Okay. Name.
Oh, this one?
That was the one I told you about. Okay, so you see what it is?
This one right here, all of
Wait a minute. Is that it? No. Nope. Next page. These right here. Okay. Anyone else? Okay.
I did some of the factoring mixed in too.
That's fine.
Sorry.
Okay. And here. All right. All right, so we are going to proceed. We have an exam on Monday, right? I just emailed the review, all right? So it should hopefully show up in your Canvas email. I'll double check that later. And we'll talk about that at the end of class here. So here are the problems you were supposed to do. On those last two problems for homework, right? These are them, right? Mm-hmm. Okay. Did anybody try and do the quadratic formula leaving these as fractions? Most of you cleared out the fractions first? Okay, you can do it leaving everything as fractions, but it just gets messy because fractions, right? All right, we are moving along here. Wait, was that the problem? Were those the problems? Here it is. This was it, right? Okay, this was, I'm sorry. Yeah, that's why. Everyone's like, what fractions? Uh-oh. Yeah, sorry, these are them. Make sure, these are them, right? Okay, all right. But this one did have a fraction. There we go. That one did. All right. How about this one with decimals? You just use decimals in the formula. So things are a little weird, but you just use decimals. All right, now we are going to move on. There's really only like one more topic that's going to be on the test, and that is graphing quadratic functions. So let's see if any of these markers work. Ooh, good one. Graphing quadratic functions. All right, so remember that at this point in this class, the only real function that we know how to graph is a line. So I'm just going to put over here on this side. Just recall that if we have f of x, that's a function, equals mx plus b, that we should all be very comfortable graphing this. You know, the slope and the y-intercept, we know how to do this rise over run. And now we're going to move on to the next category of functions that we want to be able to graph. And in this class, there's actually, let's see, I think there's five. By the end of the class, we should be able to graph 5 different types of functions. Linear functions, okay, so this is your linear function. Quadratic functions, polynomial functions, rational functions, exponential functions, logarithmic functions. So 6 functions. No, no, not today, not today. By the end of the class, by the end of the semester, by the end of the summer term, we should be able to, all right? Quadratic functions are the ones, out of those 6, these are the ones that require, well, there's a lot of detail that we want to include in our picture. You know, when you draw a line, it's just 2-point straight line. There's not much more to that, right? But with a quadratic function, there's a lot of little characteristics that we want to be able to identify. All right, so first let's look at what a quadratic function looks like. So all quadratic functions look like what we were studying a little while ago, last class in fact, and that is, it is a function where we can say y equals, remember when we introduced the idea of the notion of a function, this was like y equals mx plus b. Now we have y equals ax squared plus bx plus c. What's that?
Slope-intercept form?
That's over here. This is the slope-intercept form of a line. Now we're saying if somebody gives us a quadratic function, how do we graph it? What does it look like, right? It's not a line. Most of you are familiar with what this looks like. So when we have this, what they look like visually is you have the x and y axes, and there's actually 2 possible outcomes here that we can have. The first one is that we can have this shape that looks like this. And I know y'all have seen this before. This is called a parabola. Yes, y'all have seen that? Maybe it's been a long time, but that's called a parabola. And it can either go like this, look like a U, or it can go the other direction and look like a U that's flipped over. So in the case on the left, we will say this parabola opens up. And here we'll say it opens down. All right? So all quadratic functions, all of them, have to look like one of these 2. So since I know some of you have seen this, can somebody tell me how you can determine, just by looking at the function, how you can determine which of these 2 it's going to be? What tells you that it's going to open up versus down? What is negative? You're right, but what part of it is negative? This piece right here, this number in front, A, if it's negative, then this thing opens down. If it's positive, it opens up. So if this is like 2x squared, it's going to be this. If it was negative 2x squared, it's going to look like this, okay? So over here, I'm going to put here, this is what will happen if A is greater than 0. That means A is positive. And this is what happens if A is negative. So there's a very easy way to check which of these 2 it is. Would you all agree? If I give you a function, you can tell me, just by looking at it, if it opens up or down. Yes? Okay. Now there's some very important points on a parabola or on a quadratic function that we need to be able to identify. In this particular case, this point right here would be the lowest point on the graph, wouldn't it? And over here in this graph, this point right here would be your highest point on that graph. And that point on the graph has a special name. We call it the vertex. Let me go grab another. It's called the vertex. So remember, what I'm trying to get you to see here is that when we graph a line, these are very easy to graph, right? 2 points, draw a straight line, there's nothing else to worry about. With parabolas, we already have 2 different things. Opens up or down, we have to determine that. Then, can we find this point called the vertex? And we will be able to find it, all right? Now, back here with the line, let's take a look at a line real quick. There were 2 important points on a line that we were also able to determine. What was this point called? The x-intercept, and this one was called the y-intercept, right? Look at these 2 parabolas. Do we have x-intercepts and y-intercepts on them? Yes. So looking at this one, this appears to have these 2 x-intercepts, right? So I have x-intercept here. I have an x-intercept here. Do I have a y-intercept? Yes. Yes, I also have a y-intercept where it hits the y-axis. So that's a y-intercept. And on this one, same thing, right? We have two x-intercepts. I'm just going to put x here, and then we have a y-intercept here. So these are the things within a parabola that we need to be able to identify. All right? I'm going to summarize, I'm going to write it all down, but just if we just visually go through this, when someone gives us a quadratic function, we need to be able to determine if it opens up or down. We need to be able to determine what the vertex is. We need to be able to determine what the x-intercepts are, and then the y-intercepts. And once we have all of that information, we can draw a picture. All right? Yes? Okay, so the question is, how do you determine that? If somebody gives you a quadratic function and asks you to draw it, how do we determine all these points? All right? So I'm going to give you the steps. I'm going to tell you the procedure. All right, here we go. How to sketch a quadratic function. Also, I want to point something out. In your homework, you may see this. They talk about something in the homework called the axis of symmetry. And anytime you see that in anywhere in your homework, I just want you to ignore it. All right? But let me tell you what it is. If you go to the vertex and draw a straight dotted line right down the middle, right through the vertex, we call that the axis of symmetry. And what it is it's an imaginary line. It's not part of your graph. But what it's telling you is if you take this imaginary line, if you take this part of the parabola and reflect it over, it should land on top of itself. So this is a mirror image of itself. Over the vertex, all parabolas are mirror images. So you'll never have a parabola that looks like this, where it goes up to the vertex, like say that's the vertex, and then like goes like that. Like that's not a parabola. It has to be a mirror image of itself over here. That makes sense? Yes? Okay, so we aren't going to worry about that, and skip it whenever you see it in your homework. All right, so how to sketch a quadratic function. First thing we do, make sure it's a quadratic function, all right? That was kind of the first step that we had when we were graphing a line. We said make sure that it's a line. All right? Because if it's a line, you do one thing. If it's quadratic, you do another thing. If it's a polynomial, you do something else. If it's a rational function, you do something else. If it's exponential, you do something else. If it's logarithmic, you do something else. Right? So we have 6 different functions by the end of the class. On your final exam, if I ask you to sketch something, first thing you have to know is what you're looking at, right? Because the steps are going to change. So make sure we got a quadratic function. Okay, if we do, then we move on. The first thing we're going to find or determine is, does this open up or down? Opens up or down? And that's a question, right? Okay, now how do we determine if it opens up or down? We just talked about this, right? A is greater than 0 means it opens up. I'm just going to draw a little miniature parabola here. If A is less than 0, it opens down. So that's going to be an easy check for us. Okay, the third step, after we determine if it opens up or down, is to determine or find the vertex. All right, now I have not told you how to find the vertex, have I? I'm about to tell you how to find the vertex. There is a formula for it, all right? But before I give you the formula, I want you to notice something about the vertex. Would you agree that the vertex is a point on the graph, right? So that point has some x-coordinate and some y-coordinate, right? Well, I could just call it x comma y if I wanted to, but because it's the vertex, we give it a different, we label it differently. We don't use x and y, we use h and k, all right? So the vertex is a point. It has a number here and a number here. So like maybe this is, if you look at this, it looks like the vertex here, maybe go out 1, go up 5, something like that. So this would be 1, 5. Make sense? Over here, this vertex might be like 1 and then down 2. So it would be 1, negative 2, right? So either way, the vertex, we're going to label it HK. I'm going to give you the formula on how to find h and how to find k now. So here's how we find h. To find h, all you have to do is take negative b and divide it by 2 times a. Now, what do I mean by negative b? What do I mean by negative b? Well, that's what kind of like when you were doing the quadratic formula take-home quiz, right? In the quadratic formula, wasn't the first part of the formula negative b, plus or minus? Negative b is always the opposite of that number. So you're going to actually do that for this also. You're going to put negative b here, and then you're going to divide it by 2 times a. Whatever that number is always going to be the h. So it's always going to be the x part of the vertex. All right? Now to find k, k is a little tricky. All you have to do to find k is take this answer and plug it into the function. So that means I'm going to take the function and I'm going to plug h into it. So whatever I got for this answer, I now plug it in to the function for x, and whatever comes out, that's my k. I'm going to obviously go through a couple of examples of this, so you'll see this in action, okay? So what happens if you mess up h? You're going to mess up k, right? You have to get h right to get k right. So this is, I always see problems on tests and on students' work. They make a mistake on h, and then k is going to be wrong. Yes?
When you mentioned k is basically the answer for h, are you basically saying h equals ax squared plus bx equals, plus c?
No, h is going to be the opposite of that number,
The opposite.
right? Whatever it is, divided by 2 times that number.
Right, but when you plug in, so I guess when you're trying to get k, that's what I'm going to say.
Let me do a quick example,
Right.
okay, just so we can clear it up. Let's say we had this. Say we had that, sorry. Let's make that f of x, okay? Let's say we had that function right there. Then if I wanted to know what the vertex is, I would first find h. And h would be negative b, which would be the opposite of this number, which would be negative 4, divided by 2 times a, but a is negative 2, right? So that's negative 4 over negative 4, that's 1. Got it? So h is 1. Now, how do I find k? I take the function and I plug 1 into it. So that means I'm going to just start back up here, and I'm going to plug 1, which is this answer, into this. Negative 2 times 1 squared plus 4 times 1 minus 7. See, that answer is getting plugged in for x, and that's how you get k. So again, we'll go through these examples, but just to kind of set your mind clear on that, that's what we're doing. All right, does that help? Okay, so that's how we find the vertex. What do we still need to find? The y-intercept and x-intercepts, right? The x-intercepts and y-intercepts. So let's go to step 4. Yeah, I'll just do it here. Step 4, we still need the x and y-intercepts, right? But step 4, I'm going to have you do something kind of weird. On step 4, I'm going to ask you to do a quick sketch. You're going to do a quick sketch. All right? Now, let me try and explain why I'm having you do this step. All right? Let me explain it to you. So, can we just kind of pause on this for a second? Just pause that. I want you to think about parabolas. This is the parabola I showed you. This is one that opens up, right? And it also opens, you can have this opening down also. How many x-intercepts do I have here? 2. Okay. Is there a way that you could draw me a parabola where I'd only have 1 x-intercept?
It's all the way to the right or all the way to the left?
Maybe the vertex was the x-intercept.
Yeah, what if the vertex, the lowest point on the graph, was your only x-intercept? That could happen, right? That's a parabola. It opens up and just touches here at the vertex. There we would only have 1 x-intercept. Do you agree? Yeah? Is it possible to have none?
Yes.
What if your vertex is here and it opens up? Right? Now, if it opened down, then how many would we have? We would have 2, but if it opens up, then you don't have any, right? So in this case, you have 2 x-intercepts. This case, you have 1 x-intercept. And here you have 0 x-intercepts. And for every quadratic function, when you draw it, it's got to be one of these 3 cases. Would it be possible to have 3 x-intercepts? Not if it's a parabola. Okay, a parabola has to look like a U. So there's no way to get a 3rd x-intercept. Maybe if you drew it like this, it would, right? What if you had something like this? Now that would have 3 x-intercepts, right? But that's not a parabola. That's a polynomial. That's next, okay? So we're not there yet. For parabolas, we can only have 2, 1, or 0 x-intercepts. With me? Okay, so this quick sketch idea is going to allow us to determine which of these we're in. Do we have 2, 1, or none? Right, so let me try and illustrate. Go ahead.
You have no x and no y-intercept?
You have to have a y-intercept, always, since you brought it up. Is there any way to draw a parabola where it would not hit this? So you might say, okay, I can draw it over here like this, right? Maybe. But the idea behind a parabola is that this thing keeps on going and keeps on, it gets wider and wider as you draw it. Like this U has to like flare out on the ends forever. So eventually you will hit the y-axis somewhere. But you will only hit once. You'll never hit the y-axis twice. Can you think of a way to draw it where it would hit twice?
It was like sideways?
If it was sideways. Now that's a different type of parabola that we don't do in this class. That's where, well, we won't even talk about it. Yeah, okay. Yeah, so it would have to be sideways. Here we're saying they only open up or down. So if it went sideways, yes, but
Not in this class.
yeah, not in this class. So we are, did I address your question? Okay. So why am I having you do a quick sketch? I promise you, if you go to the tutoring lab or you open any textbook and they're giving you like a procedure for graphing a parabola, nobody ever does this step. So I want you to understand why I'm having you do it. What are the 2 things that you would know at this point? You would know if it opens up or down, and you would know where the vertex is, right? So let's say that you're doing a problem and it opens up, okay? Right? And let's say you determine the vertex is here, right? You know the vertex, you know it's x coordinate, y coordinate, you go plot the point and it opens up. What can you tell me? I have 2 x-intercepts, right? So that means you should go try and find them now, right? What if you did the problem, you went through here, it opened down, and you then got the vertex and you got this? Then what would that tell you? You have no x-intercepts, so you do not want to go looking for them, right? You're just wasting time. Does that kind of make sense? We'll work through some examples, but this quick sketch should be, the key word here is quick, okay? It should just be x, y axis, plot your vertex, and then does it open up or down? What if your vertex is here and it opens up? No x-intercepts. There and it opens down. 2 x-intercepts, right? What if your vertex is here and it opens up? 1. Down, 1, right? So you know a lot about the x-intercepts by just knowing this and this, right? So this quick sketch step, the reason for it is to determine the number of x-intercepts. All right? So we do our quick sketch and we determine the number of x-intercepts. Now, if you have 0, if 0 x-intercepts, we're gonna move on. We're going to move to step 5. So if we don't have any x-intercepts, we're just going to move on to the next step. But if we have 1 or 2 x-intercepts, we actually have to go find them now. And how do we find x-intercepts? So how did we find x-intercepts when we had lines? We set y to 0, didn't we? Okay, now in our function, when we look at our function here, let me rewrite this here. If we were trying to find the x-intercepts for this, we would need to set y equal to 0. But what's the y in this? Because there's really no y. What did we say the y really was here? It was this side, right? This is really the y. This is the output. So if we're gonna go find these, if we have 1 or 2 x-intercepts, then what we have to do is set y to 0, which means that now becomes a quadratic equation. It's that function equal to 0. I switched the order. I put this 0 on this end. But this is what you did for homework. This was the take-home quiz, all right? And the reason why we did this is because when we get to this step now, I want you to be good at this step, all right? So if we have x-intercepts, we will go find them by solving that equation. I should put here then solve this. All right. Quick overview. Are you looking at a quadratic? Okay. Does it open up or down? Use the formula for the vertex. Quick sketch. How many x-intercepts do you have? If you don't have any, move on. If you have 1 or 2, solve that equation. Now step 5. There's only 18 steps, so hang tight. No, I'm kidding. We're almost done. Step 5 is the Y-intercept. Find the Y-intercept. And we will always have a Y-intercept, always. So this step has to be done every time. There's no checking to see if, do we have it or not. It's always there. So, and how did we find Y-intercepts when we were doing lines? We set x to 0, right? Not y to 0. We set x to 0. So check this out. If we set x to 0, what are you going to get? C, right? You're going to get C. So I'm just going to put that here. If I plug in 0 for x, that's what that means, right? Plug 0 in for x. Plug 0 into the function for x. This should spit out C every single time. So that number C should always be our Y-intercept. And now the final step, step 6, is to sketch it. So your final sketch should include all of this information. All right? Y'all ready to do one? Okay, let's do one. Let's actually do the one right here. Let's sketch f of x. Hold on a second. We'll have to change one little thing on this. Negative 2x squared plus 4x. Let's go plus 7 instead of minus 7. So I don't remember if we had this conversation earlier in the semester when we first started this class, like why do you have to take this class? Like no matter what you do with your life, unless you're teaching a math class at some point, you're probably never ever going to need to sketch a quadratic function. Would you agree? Yes. In fact, you could just go to a website, type this function in, it'll draw the picture for you. There's no need. So what is the value of this? Like is there any value to this at all?
To train our brain.
There you go. I mean, that is it.
Yeah, realistically, yeah.
It has nothing to do with a parabola here. It has everything to do with, can you follow a procedure? Can you? Can your brain process information? And it's math, so you may not even like it. Can you still train your brain to follow a procedure? And so the way I've always looked at it is, going out into the workforce, if you eventually want to get a job, you have somebody who has a college degree and somebody who doesn't. Who are you going to hire? Now, maybe the person without the degree is a much better person to hire than the one with the degree, but the degree, what it's telling you is that person is capable of learning. They are teachable. And not only are they teachable, they can learn a lot of different things that they may not necessarily care for, like mathematics. So if I have to train you to go use a copying machine, right? I know this seems trivial, but if it's your first day on your job and they're like, hey, here's the copier, here's how you run it, and they show you, can you like get that procedure in your head, lock it in, learn it, or do they have to show you that every day for the next week, the same crap over and over because you just can't process information, right? Does that make sense? That's kind of the way I try and look at it is, you know, are you teachable? Can you learn? Here's a procedure. Let's see if we can execute the procedure or not, all right? First step.
Is it a quadratic?
Is it a quadratic? Yes. Oh, I forgot the sticks. Yes, yes, yes. We have our sticks. Let's see if Elizabeth is here today. Yes. Okay. So I'm calling the people who weren't. So Elizabeth, it is a quadratic, right? You know why it's quadratic?
Yes, it has ax squared.
Because of the square, right? That's the key. We have to have the squared term. We could have nothing else here. As long as we have squared, it's quadratic. All right? Elizabeth, does it open up or down?
So -2.
Uh-huh. So a is -2. That's this number. And that is less than 0, right?
Yes.
So it's going to open
Open
down. If you want a quick way remembering that, like if A is positive, positive people smile, right? Negative people frown, right? Down, up. All right, third step. We're going to keep going, Elizabeth.
All right.
Okay. So the vertex is next, Elizabeth.
So it's going to be
We're finding H first.
finding h. So
Okay.
it's, -4
-4.
over 2 times -2.
Okay, good. Now just asking, Elizabeth, what if this was -4? If this had been -4, then what would I have put here? +4, okay? All right, so this is good. So -4 on top, -4 on the bottom. This is just 1. All right, we'll let her off the hook. Is Nivani here today? Hi. You get K. Yep, you have to plug it in. So I'll help you out, all right? That's what I really wanted to hear you say is you have to plug it in. You have to plug 1 in for X. That means everywhere you see an X, you have to replace it with 1. I'll give you a few seconds there, Nivani, to see how that goes, see what you get, and then we'll see if people agree with you or not. Go ahead, go for it.
Well, for the -2 times 1 is just -2.
-2.
So is that 1?
The squared is only on the 1. So this is important. See this squared right here? It is only impacting the x. The -2 is just going to multiply after you square.
So it's just -2 times 1.
-2 times 1, so that's -2, right? And then you have plus 4 times 1 is 4, and then plus 7, right? So what does that give us? 9? 9. Positive 9. Okay, so Nivani, you just helped us get the K, right? But the vertex is actually both of these pieces, and it's a point, right? So I'm going to put here, I'm going to put the point 1, 9, and I'm going to even tell you, remind you, this is a point, right? Is Aaron here? Aaron? Aaron, this point 1, 9, is it the highest point on the parabola or the lowest point on the parabola?
For this one, it'd be the high.
It's the highest. Why are you saying that? Because it opens down, right? Because this thing opens down, this point 1, 9 has to be the highest point on the parabola, right? Okay. What's our next step, Aaron? Quick sketch. All right, so let's do our quick sketch step. And this is supposed to be quick, right, Aaron? Okay, so here it is. So I'm going to plot the point 1, 9. To the right 1, up 9. I don't even care. I'm not even going to count it. It's to the right and up. Yes? To the right and up. And Aaron, it opens which way?
Yeah.
Down. So if it opens down, Aaron, am I going to have x-intercepts? I'm going to have 2, right? I'm going to have 2 x-intercepts. See them? I have 2 x-intercepts. Do y'all see how that works? If you don't do this step, you could wind up going and trying to find the x-intercepts and determining that you don't have any. And you waste, like, I don't know, however long it takes you to run the quadratic formula. You've wasted that time. How do you think you would know you have, let's say we had no x-intercepts. How would we know that in the quadratic formula? What would tell us we have no x-intercepts? Did it ever happen on your homework where you were doing a problem and you got a negative underneath the square root? And we said no real solutions there, right? That means no x-intercepts. But we're going to avoid that because we're going to do this quick sketch where we should never get negatives under the roots. Because if we don't have x-intercepts, we're not even going to do the quadratic formula. All right, so Aaron, we have them, right? So we're still in step 4. We have 2 x-intercepts. 2 x-intercepts. So that means Devon? Devon? No. Devon may not be around anymore. Marcus. Okay, Marcus, you're up. Marcus, 2 x-intercepts. So what do I have to do in step 4 if I had 2 x-intercepts? Yeah, we're gonna set this thing up and use a quadratic formula. Well, are we going to use a quadratic formula? So when we take this equation, right, we set our function equal to 0. That's the step. We want to look at this like we did last class, which is, is the constant missing? Is the x term missing? No. All of them are there, right? And when all of them are there, you had 2 options, factor or quadratic formula. But I sent you home to do quadratic formula, right? Because it works. As long as you can execute it, then it works. So let's just go quadratic formula with this, all right? So why don't everyone take a minute to do that? I want everyone to run the quadratic formula on that. Here it is, the formula in case you have forgotten it. Negative b plus or minus square root, b squared minus 4 times a times c, all divided by 2 times a. So let's see. I'm going to give you a minute and a half to see how far you get with it. You should give me 2 decimal answers, 2 decimals. You got them?
Yeah.
Let me see what you got.
I don't know.
3.12 is right. The other one seems off a little bit. Yeah, there you go. Okay, something must have gone wrong when you typed it in. Did you get them? Oh, question. Okay. That should be, okay, so remember we said we're going to count the number of negatives you see. You were here last time, yes?
Yeah.
Okay, so remember in the formula right here, I said count the number of negatives you see. So how many negatives do you see? 2. If you see 2, an even number, it's plus. This should be a
Okay,
plus,
so then
okay?
that's a plus.
That's a plus, and that'll make it work,
Okay.
okay?
Yeah, 'cause I know you can't do
Yeah, I can't do the negative. We all good here? Let me put these answers up, okay? Well, hold on. I said we're not quite there. Let me go another 20 seconds. X equals negative 1.12 and x equals 3.12. Those are the two x-intercepts you should be getting through the quadratic formula. So I'm not going to take time to go through that on this one. If you got these wrong, let's talk after class. We can make sure you're doing everything correctly on your calculator. All right. Can I proceed?
Yeah.
Yep. All right. So now the next thing is Laura, okay? Okay, Laura, what's our next step? I forgot what we were doing.
Do we sketch it?
What's step 5? Because we're on 4, right? We just finished 4. So what?
Find the y-side.
Y-intercept, right? And I said there's a quick, easy way to find the y-intercept. You just look at the original function. What would it be for us? Look at the notes. What did it say the y-intercept was? C, right? So look at this original function. Remember, it was ax squared plus bx plus c. So what should our y-intercept be here? 7. All right, so step 5, just going to squeeze it in right here. Step 5, our y-intercept was c, which in this case is 7. All right. All right, so there we go. Now, final step, step 6, sketch it. So step 6, here comes the sketch. All right, so the way we do the sketches is this. Draw our x and y axes. We start to put the information we have down. Now let's go back to the very beginning. We determined that it opened, in this case, this one opened down, didn't it? Okay, so let's keep that in mind. It's opening down. We found the vertex. The vertex was the point 1, 9. So I'm going to go out 1. I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to label this 9. I'm going to draw a point here. And this point right here is my vertex. I'm actually going to label it 1, 9 so everyone knows what that point is. That point is the highest point on the graph, right? Aaron told us that. It was going to be the highest point on our graph. Our graph opens down, right? So now let's go and use the x-intercepts. The x-intercepts are where our graph hits the x-axis, and it should happen at negative 1.12 and 3.12. So let's start with the negative 1.12. Negative 1 would be here, agreed? Negative 1? Negative 2 would be here. So negative 1.12 would be just slightly to the left of this somewhere. And look, again, we said this, we're not putting a man on the moon, so we just want to put a point, close. That's good enough. Is that all right with you? And then I need 3.12. So here's 2, here's 3, here's 4. So a little bit to the right of 3 would be my other x-intercept. And what was the other thing that we got? The y-intercept. The y-intercept was 7. Y-intercept means on the y-axis. So on the y-axis, if I go to 7, 1, 2, 3, 4, 5, 6, 7, here at 7, I have that point right there. Okay? And now I'm ready. I've put down all the information, right? Everything is here. I need to draw it. And this is the only time where that idea of an axis of symmetry is helpful. I'm just going to put this here. You don't need to draw this. In fact, I'd prefer you don't, because this is not part of our graph. This is just kind of to help us remember that whatever we draw, it needs to be a mirror image of itself over that line. Okay? So I'm about to do a drawing. Very critical point right now. When I draw this, it's going to look like this, right? It's going to look like a U that goes down. It is not going to look like a V. It does not have a sharp corner. It has a curve at the top, right? I will take off if you draw me that, because that's a different function. That's an absolute value function. It's not a quadratic function, okay? So that means I need to somehow round this top off, and I'm kind of just going to connect the dots at this point. I've got to just go through here, and then go through here, and just kind of keep going down. So I'm going to start with this side. Do my best. Okay, there we go. That's not bad. And then I'm going to do the same thing on the other side, just kind of mirror image of it. So what do y'all think of that? That pretty good? That sucks, right? Okay, and I don't want yours to look like that either. I want yours to be, as best you can, a mirror image of itself. So, you know, one thing you could do is say if I'm that far away here, I can just kind of imagine being that far here, like that. That can sometimes help you. Oh, what happened to my marker? Here we go. Better? Yeah. Yeah, okay. So we do our best, all right? The main thing I want is, you know, round this off, make sure that you go through your points, all right? And when you're done, if you take a step back, it should look pretty close to a mirror image of itself, all right? That's it, we're done. Now, what if you do a problem? Just imagine that you did a problem. You went through all the first 5 steps, all right? You went through all the first 5 steps. And then you went to go put all your information down. And let's say you had this. Vertex, X-intercept, X-intercept, Y-intercept. So this is your vertex. I'll put V here. And it opens down. What would you be thinking to yourself at this point? You messed something up, okay? Because there's no way you're drawing this to make it look like a nice symmetric U. And I'll see students on a test do this, and they'll draw this for me. They'll do something like that for me, you know, and they're like, there you go, that's it, you know. This is an indication that something is wrong. Most likely for this problem, most likely this student got their signs wrong on the quadratic formula. Like instead of, like this one should have been over here, this one, I mean, it's usually something like that. Sometimes the vertex is out of place. Sometimes the vertex, you know, maybe should be here or something. So anytime it just looks like your picture's not going to come out right, should be a red flag that you need to go back and look at your steps. All right? All right. So that's how you sketch one. Now I'm going to put another one on the board. It's still going to be a pretty basic one. I'm going to let you do it on your own, all right? We're with each other. And I'm going to give you, I don't know, 10 minutes to see how long it takes you to graph this. See if you can get it done in 10 minutes. Okay, sketch f of x equals x squared minus 6x plus 2. Okay, so go through the 6 steps. Check with your neighbor if you want to. Y'all can work together, I don't care. Just remember, on Monday you're going to have a test over this exact topic. So I'm just going to step out for just a moment. I'll be back.